Okay, homework 1, piecewise functions and greatest integer functions. So this first set, we have this one piecewise function, a of x, and it's got 3 different pieces of its domain. And these first 6, we're using the same function for all of them. We're just taking turns plugging in different values. And so the trick is figuring out which piece of the domain the number is going to fall into. All right, so this one, a of 8, we've done function notation like this before. It means start with function a and plug in the number 8. The trick with these is that there are 3 separate pieces. The very first thing you have to figure out is if I'm going to plug in 8, which of these 3 pieces am I going to plug it into? So the first piece is for numbers that are less than or equal to -6, which it's not. The second piece is numbers between -6 and 1, which it's not. So it falls into this last piece, numbers that are bigger than 1. So you know that you're going to take this 8 and plug it into this third piece right here. So I'm going to write that third piece, except in place of my x, I'm going to sub in an 8. And then you just simplify that value down and you should have a numerical answer for this whole first section right here. So -4 times 8 ends up being a -32, and then I add 7 to that. So -32 plus 7 ends up being a -25. And that would be your answer for the first one. All right, and then we're going to do one from this graphing section down here. So remember, what this means is you essentially have 2 different graphs on the same coordinate system, except you only want them to go from a certain range, left to right. So the way that we do these is we graph them just like normal, using a pencil or something that you can erase, and then you want to shift the domain and make sure that this piece is only for these x values and this piece is only for these x values. All right, so I'm going to start with 5x minus 2, and I've got a pencil, so I'm going to plot these before it's actually my final answer. So 5x minus 2, this is just a y equals mx plus b. So I'm going to start with the b, which is -2. So I'm going to go down to -2 right here. And then my slope is 5. All right, so that means I'm going up 5 to the right one, or I could completely reverse it and go down 5 to the left one. So I'm going to go up 1, 2, 3, 4, 5 to the right one. I'm also going to do one in the opposite direction. I'll go down 1, 2, 3, 4, 5 into the left one. All right, so this is all done in pencil, so I just want to make sure I'm kind of doing just a light sketch of this right now, and then at the end I'm gonna either darken it or go over it with a pen. Second one, x minus 7, and then we'll talk about that domain in just a minute. So we're gonna graph this. So x minus 7 starts with a y-intercept of -7. So we can go down there, that's -2, 3, 4, 5, 6, 7. So we'll start with that as our y-intercept. And then the slope, remember there's technically a 1 anytime you see an x like that. So our slope is just up 1 to the right one, up 1 to the right one. So we go up 1 to the right one, up 1 to the right one. Get just a couple points so you know what the graph is going to look like. And so we connect the dots here again, just with pencil, just to give a quick sketch of what this graph is going to look like. So now once you have the sketches, and this is stuff we did in a previous chapter, once we have the sketches, now we're going to pay attention to this domain. Okay, so this first one only goes up to an x value of 1, and then we're going to cut the graph off there. Okay, so here is our x value of 1 right here, if we take a look. So that's x equals 1. So it goes up to this point, but then it stops. Okay, so what I'm going to do is I'm going to erase any piece of the graph that happened after that point. Okay, so anything that has a bigger x value than 1, I'm going to erase it. It's a terrible eraser, sorry. Okay, and then the other thing you need to look at is the actual inequality sign itself. So this is just a less than, it's not a less than or equal to. So the actual point that has an x coordinate of 1 needs to be an open circle. Okay, so I'm gonna go all the way up to an x coordinate of 1, but then I'm gonna leave an open circle on that point. Okay, so that's my final piece. So I am going to have an open circle at x equals 1, and then any x value that's smaller than 1, I'll be using this line. Okay, so that's the first piece. Second piece, x minus 7, which is this line, for any value that's greater than or equal to 1. Okay, so again, find that x coordinate of 1, go down here. So our graph is going to start there, and it's going to start with a closed circle because it's less or it's greater than or equal to. So I am going to erase anything that I had over here. Okay, so now any part of the graph that had an x value that was smaller than 1, I got rid of. So just to darken it, it is going to start with an x coordinate of 1, and it's going to be a closed circle because this has the or equal to, and then all of my x values that are bigger than 1. I'll take those. Okay, so that is what my piecewise function should look like. Let's talk domain and range. So the domain is all the possible x values that get hit. Range is all the possible y values that get hit. So if we look at my arrow, this arrow, it's pretty steep, but technically if I were to keep graphing it, it just keeps going off to the left. Very, very slowly, but it keeps going. And then this graph cuts off at an x value of 1, but it picks right back up where the other one left off. So there's no gap in the x values. And then it goes all the way off to the right. So every single x value gets covered, and whenever every single x value gets covered, remember you write that down as all reals. So we have our little set notation, and we have our double block R saying that it will be all real numbers. Okay, and then for our y values. Our y values, this means we keep going down, goes up to here, and then this piece stops at a y value of 3. That's as high as this piece ever gets, but there's this overlap here, and this ends up continuing on and covering all of the values that are bigger than 3. So this piece goes all the way up to 3. This one could very easily pick up where it leaves off and then keep going beyond a value of 3. So all of the y values end up getting covered as well. Okay, with a lot of these examples and a bunch of the ones we saw in the notes, there was a gap in the y values or the x values, but here there is no gap at all. So if you were kind of to look from left to right, there's no gap where x values don't get covered. And if you were to look up and down, there's no gap where y values don't get covered. So that is going to be all reals for the x's and the y's.